Okay, so today we're going to work on number 55 from chapter 21. The problem reads, the magnetic field produced by the solenoid in a magnetic resonance imaging system, or MRI, designed for measurements on human bodies has a field strength of 7 Tesla. And the current that runs in the solenoid is 2 times 10 squared amperes. The question is, what is the number of turns per meter of length of the solenoid? And you have to note that the solenoid used to produce the magnetic field in this type of system has a length that is not very long compared to its diameter. Because of this, your answer will only be an approximation. So, a little bit of background info. A solenoid is a coil of wire wound in the shape of a helix. There we go. Inside the solenoid, the magnetic field is nearly constant and has a magnitude that is related to N, the number of turns per unit length of the solenoid. And it's also related to I, the current in the wire. The constant mu, which is known as the permittivity of free space. Let me add that. Permittivity of free space relates the current in the solenoid, the magnetic field, and the number of turns. So in this problem, the magnetic field B is 7 Tesla. The current I is 2 times 10 squared amperes. And then we have to find the number of turns, N. So luckily, there's a very convenient equation that relates all of these terms. So that for a solenoid, B, the magnetic field, equals the permittivity of free space times the number of turns times the current. If you rearrange that, you get the number of turns equals the magnetic field over mu times the current, which once you work that out, you do your math, your algebra. 7 divided by 4 pi times 10 to the negative 7, which is the permittivity of free space, and also divided by 2 times 10 squared. That gives you 2.8 times 10 to the 4th turns per meter. And the reason it's turns per meter is because, well, that's just what we're looking for. That's the unit for N, turns per meter. All right, so that's how you solve number 55.